from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada, with me, Mr. Lady Ada, and we're broadcasting live here from the Adafruit factory in downtown Manhattan. We've broadcasted for the last 10 years or so. This is where we do our pick and placing, our machining, our coding, our videoing, manufacturing, our kitting and soldering, and more. It all happens here, but right now it's resting silently. A lot of people are at home, and we're getting ready to do the show. So that's why, even though there's a factory, there's not a lot of activity. Yeah. Sometimes we do shows during the day. You'll see some people running around. But why don't we kick it off? And Mr. Lady Ada, why don't you tell them what's on tonight's show?
On tonight's show, the discount code is SPI Flash, 10% off in the Adafruit store, all the way up till 11:59 p.m. Eastern time tonight. It could be Spifflash, or Spy Flash, or SPI Flash. That's the code. Use it and get 10% off anything we have in stock in the Adafruit store, all the way up.
Including the new products.
Yeah. We'll talk about some of our live series of shows, including the show and tell. Do a little bit of time travel, where we're going to talk about some big news with AdaBox. Probably guess what it is. We'll be shipping eventually. We have some updates from the mailbag, your letters to us, some help wanted, jobs posted on the jobs board at Adafruit, jobs.adafruit.com, some cool factory footage, some neat 3D printing from Noah and Pedro. We have Ion MPI this week. It's from RichTech, your power partner, DigiKey and Adafruit. We'll talk about that. We're going to do some new products. We'll answer your questions. We do that over on Discord, adafruit.it/Discord. Join all 35,000 of us. We hang out there quite a bit. You can show and share your projects and more. You can also, go on Mastodon, but we got this thing going over.
Yeah, we're sticking to this for now.
We got this thing going over here too. All that and more on Ask an Engineer. Okay, so let's first pay some bills. SPI Flash is the code. When you start putting stuff in your cart,
we have freebies.
Yes.
We have freebies when you order from Adafruit.com. $99 or more, you get a free PermaProto half-size breadboard PCB. It's a lovely PCB with gold pads, and it looks like a solderless breadboard. So it makes it really easy to take your project and make it semi-permanent. We've also got the KB2040 at $149 or more. It's an RP2040 based boards with a stomach QT connector, castellated pads. It's Pro Micro compatible and shaped. It's designed for keyboards, but you can use it for a lot more. And it currently comes in pink, but we're going to eventually run out of pink. So if you want the pink boards, now's a really good time to order, because once we're out of the pink boards, I don't know when we're going to get them again. Free UPS ground shipping at $199 or more in the continental United States, and $299 or more, you get a free Circuit Playground Bluefruit. Wow! It's an NRF52 840 based board, a powerful BLE Cortex M4 chip. It's got buttons, LEDs, alligator clips, switch, accelerometer, sensors, and more. It works with MakeCode, CircuitPython, and Arduino IDE.
All right, and don't forget, when you make an account on Adafruit.com, we offer two-factor authentication. You should do that. You should do that on all the sites you use, but we also offer that.
It's a good idea.
As well, especially for things on our website we don't allow just guest accounts on, such as Raspberry Pis. Okay, we did some live shows today. We do live shows every week. We had a bunch of live shows coming up too, and some updates. We just did just show and tell. Every single week, I try to pick out a project or something. I'm gonna say there's 3 this week.
Well, the theme was lickability.
Yeah. Well, Aaron showed a really neat underwater how-to guide on how to make your projects work underwater, essentially in like very harsh environments like saltwater. So we're going to show that video and that guide.
Yes.
That was really neat, just to see the video of Aaron in a full mermaid tail.
It's so hard to do what she did. I mean, like, she's the best at this.
Yeah. And then I also liked, so Paul, who does the CircuitPythonShow.com, if you haven't, check out the latest episode. He went and visited someone who uses CircuitPython for like this cool installation. Trolls were involved, good trolls, not the ones on Twitter. And check that out. And then last up, DJ Devin did a really cool costume and kind of put all, like, there's like a bunch of a big bunch of Adafruits. I'm not going to ruin the surprise.
A showcase.
Yeah, I'm not going to ruin the surprise, but it's really neat because you can jam a lot of electronics in a mask and a thing, and you can hear some of the results from the debut giving out candy.
Some kids were super scared, which is great.
Okay, on Sundays we do From the Desk of Lady Ada. We do it in 2 parts. Part 1 this week, what did you show off?
Okay.
Lady Ada?
So part one, I actually showed, I've been doing a lot of revisions, and you're going to see that in the store. A lot of our TFTs I'm revising to add iSpy connectors to make it easier for people to connect displays. So this is a capacitive 2.8 inch display with iSpy connector. And then I also showed the prototype of the RP2040 Scorpio board. This is a board that we actually designed a year ago, and then I couldn't get parts, and then I got distracted, but it's coming out. So it's got 8 channels of level shifted 5-volt output, all on one PIO contiguous 8-pin space, and so it's designed to be used with the NeoPixelate library to drive 8 NeoPixel strands. The RP2040 is a great chip for that because it has a ton of RAM and it has PIO. So I think this will be really useful for people who want to do big NeoPixel projects, maybe for the Halloween, the holiday.
On a Halloween.
On Halloween.
So we also do from the desk of Lady Ada the Great Search. We do that with DigiKey. And this is when Lady Ada uses her power of engineering to help you find things on digikey.com, which is a good skill because we're still in a bit of a part shortage, parts constraint. But what do you help people find this week?
Well, this week, what's interesting is I sometimes I do little throwbacks to what I think are simple components, but I forget not everyone knows about, which is resistor packs. I've used resistor packs since we were doing kits. I used them on the Scorpio board to add inline resistance to reduce the not jitter, the ringing effect of high frequency signals going over long cables. 100 ohm resistor helps just tamper down the capacitance and inductance of those wires to reduce ringing, which is good for NeoPixel drivers. But I didn't have a lot of space on the board. So I showed how you can spec resistor packs. I use 4-pack, but there's also 8-packs. There's bus, there's isolated, how to figure out the sizing and what I use them for. And also when you might prefer to go with resistor packs instead of individual resistors when doing manufacturing.
Okay. On Tuesdays, we do JP's product pick. That's when we broadcast live inside of a product page, and you can get discounts. Here's this week's highlight.
The Feather ESP32S3 with 4 megabytes of flash and 2 megabytes of PS RAM. This is a familiar Feather format, so you can use all of the different Feather wings and such that you want to. It also has a Stemma QT connector mounted right there, right on top. The ESP32S3 has Wi-Fi capabilities, which means it's a really great IoT board. You can use it with Adafruit I/O, you can use it with Whippersnapper. This is actually Doom running in real time on the board. I can't play it, but it's playing itself. It's running through demo loop. But that's kind of amazing. That gives you an idea of the type of power that you have on this board. Yeah, more than enough power on the Feather ESP32S3 to drive a real-time Doom experience. And oh, look at that screen. I love that. Looks really good. It is the ESP32S3 Feather with 4 megabytes of flash and 2 megabytes of PS RAM.
Okay, and this Thursday, JP is off, so you will not see JP's workshop. There'll be a blog post that reminds folks, but if you happen to be around in the Discord channel, let folks know. I think we update the schedule, but probably need to update it tomorrow as well to let you know it's not going to be broadcasting tomorrow. And then Friday we have deep dives with Tim, 5 p.m. Eastern time. Let's do some time travel. Okay. So time travel this
Let's look
week,
at the future and the past.
Yeah, and the present. The best way to predict the future is often to just look around what's going on now. So this is hot off the press. Right before we went live, Make's board guide was announced. They do one every single year. They do it in partnership with DigiKey. And there's one of our boards on the cover.
Pink PCBs.
Yeah, pink PCB. And if
I
you're...
think there's the TD Pico there too. That's great. Unexpected Maker had a board.
Yeah.
Looks like the Pico W.
If you're a Make subscriber, I think you can log in and look at it now. I happen to be a Make subscriber, so I'm going to log in or check this out. I have the app version too, but I haven't had got a chance to look at it. I suspect there's going to be a lot of boards from Adafruit, and I also suspect there's going to be a bunch of things that can run like CircuitPython, for instance. So kind of cool. I don't know for sure, but this might be the first time a pink PCB has ever been on the cover of a magazine.
That's nice. Looks like it's hard to see.
This is the first. Well, this was the first time there was like a pink-haired engineer.
I know.
And
well, I gotta keep the style.
yeah, this was from Glamour magazine. So this was the first time there was a pink-haired engineer. So now you've got a pink PCB.
Pink. What's funny is actually I'm revising the Feather RP2040 soon. I wanted to just make a couple little tweaks. We'll get back to pink eventually, but I did like the little pink party.
Yeah. So that's kind of cool. And then a little bit of a reminder. So next week on Tuesday, Adafruit, we have a paid holiday for our entire team to go help out with voting, be poll workers, to go vote. In addition to, the companies are supposed to give people time off. We decided
We do, but in addition,
let's make it a national holiday here. So please check out the website. When you check out the website, adafruit.com, you'll see what we have for the shipping times and deadlines and everything. My suggestion is if you need something shipped overnight, might not go out on Tuesday, so order it on Monday or on Wednesday. Might still go out. We have some of our team, but a lot of us are doing a lot of civically minded things this year.
Yeah.
Okay. And the big news that we want to talk about, AdaBox news this week. All right, so great news. AdaBox returns 2023. We finally have enough parts to do the 4 AdaBoxes we want to do. All this year, not possible. The chips we needed.
Sensors, modules, components, level shifters, diodes.
We can get dozens of things. We can get hundreds of things. We can get thousands of things. It was hard to get tens of thousands of things. And AdaBox subscribers can be into the thousands. We also had to not allow new signups. So AdaBox has been in stasis for the year, and thank you everyone who's been patient. We've been doing updates. This video is so when we update the website, we do the blog post, and then we send out an email, folks can see that it's not like a phishing scam or anything. There's nothing you need to do at all. You can always cancel your subscription if you want. Just keep in mind.
We don't charge until it ships.
Yeah, we don't charge until it ships, but just keep in mind, there's so many people signed up for when someone leaves AdaBox that if you do leave, you might not be able to get back in. So it is good news. We're finally able to predict what's going to happen. We'll be shipping the first one March-ish of 2023, if not sooner. And the parts are here. Thanks to all of our partners like DigiKey. It's just been tough to plan something that has tens of thousands of customers and not be able to know
and do
that
a good
we're
job
gonna,
and
well,
make
not,
sure that we can
and not know we're going to get it.
Yeah.
Like we're just starting to see some parts that we needed available for something as large as AdaBox. So we didn't just want to do one AdaBox last year. In fact, there wasn't anything that we could do just one AdaBox. We were close. And there's some things that we had to migrate away from. So we had one AdaBox that relied on a Microchip the company. And they're still saying end of like 2023 until we get those chips. So we had to redesign the board. Now it's going to use maybe an RP2040 or an Espressive ESP32S2. So hooray, it's here. We'll get the word out. Thank you, everybody. And this is the video that goes along with all the information we're going to get over the next week or so to everyone. But stick around if you want an AdaBox. But if you want to leave and come back, that's totally fine too. Just remember, if you have an AdaBox, you don't get charged until we ship. So you'll see that at the beginning of probably March. All right.
Letters. We get letters. We get tweets and we get emails. Your comments via our...
We get your letters. All right, this week. Hello, I wanted to send a thank you for your product. I had a vision, what I wanted, and only your product fit the bill. We were designing a nerdy room, and I wanted to make some of our old NES games look like they were glowing. With your induction coils and LED lights, it was made possible. And I was one of the prouder accomplishments we had for that room. Thank you again. I know to check out Adafruit first for any of my next creative ideas.
Oh, that's great.
Thank you.
I love those inductive LEDs.
Yeah. Okay, help wanted. This is from jobs.adafruit.com if you want to post your skills up, if you're looking for a job, or if you're a company looking for people. There's two. Both of these are really neat. One is a vertical farm maker. You've probably seen pictures of those where things are growing using either hydroponics or a variety of ways to make plants grow vertical indoors with artificial lights. And there's an NYC flood net sensor engineer. About 10 years ago, New York got hit with Sandy, and it flooded everywhere, and they're still trying to figure out how they can avoid some of the same problems happening again, or at least alert people if something like does happen again, with oceans rising and water levels rising it seemingly all the time. This is probably a good thing. So if this is something that's interesting to you and you want to help folks, check out jobs.adafruit.com. Okay, Python and Herbert time. Okay, so in the hardware newsletter this week, there is a Halloween roundup.
Yes.
So check out all of these things.
So many skulls.
You can see all of the things made with CircuitPython and
pumpkins
and candy-carrying devices and you name it, if it has sound or audio or whatever. I have a bunch of news, but this week we're going to focus on a very specific story which we have on our website. And it's called Uploading UF2 Files with macOS 13.0 Ventura. We tagged Apple, Microbit, Raspberry Pi. Everyone is having this issue. Raspberry Pi has a blog post about this. Microbit folks reached out to us. Lady, what's going on with this latest version of macOS? Because it seems like this happens every time there's
This is not the first time this has happened.
Major version of macOS.
Well, it's also happened, I think, with Microsoft. I think one of the first Windows 11 release candidate, like previews, also had this issue. So basically, Microbit and Raspberry Pi and Adafruit, and everyone who's using our code, which includes like Seed and SparkFun and more, we use UF2 and fake mass storage bootloaders to load code, and that's because it's really hard to get people to install things like ESP or to install Python, or sometimes you can't if you have a Chromebook. They're locked down, so you don't have access to command line tools. Whereas mass storage is a universal interface for USB, and so having USB be the way that people program microcontroller boards has been revolutionary for the last 5 years, which is super awesome. So that's great, and it's been originally there was bootloaders that used mass storage. But until Microsoft came around and developed the UF2 standard, it was really hard to do that reliably. And they actually did a very smart job of figuring out how to do it in a way that every major operating system, Linux, Mac, and Windows, could write to these drives cleanly without errors, and it worked like every time. And that's been like for the last 6-7 years or so. Like everyone's been using this. Again, Microbit's been using this technique. Raspberry Pi built it into their ROM bootloader. Adafruit's been using this. All of our boards that we use UF2. It's been great. However, in the latest version of macOS 13 Ventura, the Finder, when you drag and drop files, it does some sort of like read back thing. We're not exactly sure. There's something that changed in 13 from 12, where it does not like these small, fake mass storage devices, and there's no reason it should have this issue. And again, it's happened in multiple other operating systems, but it's just what's one of the things when you get the latest beta alpha release of an operating system. Like this has happened before, and sometimes it takes a couple months, and then we get it fixed, and then it's fixed, and it's wonderful. So we're still trying to get in touch with Apple to be like, hey, you decided to do something that's non-standard. And broke this way of when you drag and drop a file, it should just write the file. It shouldn't try to do anything else, and that's how it's been for like 25 years, 30 years on computers. Please don't go back and do something different. Or you can just always downgrade to System 7, which in my opinion was the best Mac OS system version.
On our blog post, we have what you can do to help, and also Raspberry Pi does too. So if you go to raspberrypi.com and look at the post Ventura problem, they have instructions on how to report this to Apple using the feedback assistant.
And that will actually be really good because, to be honest, the more people who bring it up, it's not like, oh, like they're getting these complaints. It's they actually look at the volume. If they have a lot of people saying this is an issue, they know it's important and they'll fix it. And I know they'll fix it because this has come up before and it's gotten fixed
they
before.
just need to find out, does anyone care that this is broken?
Yes.
So be nice and everything. Just let them know, hey, like, you know, this thing that we all use for, especially kids learning electronics and coding with microbits, with Raspberry Pis, with Adafruit stuff. You could use a feedback assistant. There is a feedback number which is FB11725030. And then you can also check out the GitHub issue that Raspberry Pi has open. We have a summary of all this. There is a workaround where you can use like terminal. You can also use other things.
There are a couple things, but it really would be...
That's probably not what most young folks are going to do when, like, the whole simplicity of how a lot of these things work is you just can drag and drop files instead of installing IDs and all that.
So to be honest, you know, if you use UF2 a lot, if you're using Microbit, if you're using RP2040, I don't recommend updating to Ventura at this time, because unless you're comfortable using these command line tools. You know, Ventura is ultimate bleeding edge. You don't have to upgrade for security reasons. You don't have to upgrade for support reasons. In fact, you know, and people who run Mac OS on the cutting edge, like, you know, it's whenever you get the latest version, a lot of stuff. I mean, your mouse stopped working once.
I had to.
Did you email the mouse developer?
Yeah, there's a lot of things that happen. So I have a production machine, and then I have a machine where I'm like, let me start to see what's going to break with this new OS. Ventura's been okay. There's a couple of things about it. If you don't read all the things it does, it's like, huh, that's weird. So my, computer was next to my phone or iPad, and my mouse went from one thing to another. So my mouse went from my computer to an iPad. I'm like, whoa, that's a weird thing that I didn't expect to happen. Like, why is my mouse on another device? It's cool. It's a cool thing. But you have to remember, like, oh, like, turn this off and stuff.
And I will say, like, it's because, I also have people, like, we have people who are, like, still running Windows System 7, which, again, was a great system version for Windows, but really is quite old. It's over 10 years old. Microsoft has a bit of a thing where when you upgrade the Microsoft operating system, everything is backwards compatible because it's extremely important to them. Yeah. Apple has a slightly different philosophy, and there's no right or wrong philosophy, but they prefer to break things. They do not care about backward compatibility as much. And so I will say, if you're an electrical engineer and you're doing a lot of engineering and development, if you're on Windows, I recommend always updating to the latest stable. But with Mac, I always wait.
Move fast and buy iPhones.
I wait on the Mac because of this comes up so often.
Well, hopefully someone at Apple will see all this too. Yeah. And, this happens each time when there's a major OS update, so hopefully they'll check it out. So like I said, you can look at Raspberry Pi, get our site, file a bug report with them. They make it pretty easy. And that's this week's Python hardware news. Okay, we're an open source hardware company. We have 2,761 guides. Lady Ada,
a lot of guides this week.
What is on the big board this week?
Glad you asked. Okay, we have a new page on the how to add a new board to Circuit Python guide. We do have a requirement that if you're submitting a new board, you cannot use somebody else's USB VID PID. Some people ask why. Why can't I just gank your VID PID and use it for my board? And there's actually really good reasons for it. And we lay out on that new page why, and also how to get free USB VID PIDs for your open source board, or if you're using a microcontroller from one of the more popular microcontroller vendors. But it's not optional. We really do need there, and there's a check even. Your board will not get merged if it's using somebody else's VID PID, and please do not borrow from other people. It's not polite and will cause problems later. Believe me, in Arduino we went through this, and it was there was a lot of issues that were caused by it, and so in CircuitPython, I kind of made the call. You need to have unique identifiers.
Okay. And then other guides. Do you want to go through these?
Oh, right. Sorry. I usually start from the left to the left. Second one, Google Assistant for Braincraft. The instructions changed. Melissa revised the instructions, and so it wasn't working. Something changed with how you set up Google Assistant. If you were having issues with this guide, please check it out. It's kind of cool. You can use a Raspberry Pi 4 and create your own DIY Google Assistant, and also like get the text so you can actually do custom commands with it. So it's like DIY voice assistants. For the Magic Band Reader, we'll have a video that's from Noah and Pedro. This is neat. It's using RFID Wiz, which is by friend of the Fruit, James DeVito. He made, because he does a lot of interactive displays that use RFID tags. So he made a board that can learn and react to RFID tags without having to do any coding, and then mix that with CircuitPython to make a cool Magic Band Reader if you're a big fan of the mouse park. We also have a new guide from Erin, Light Up Costumes in Harsh Environments,
Yeah, we're gonna show that video soon.
which we chatted about. We also will show the video. Erin she works at a dive bar. It's not a dive bar like a sketchy place. It's a dive bar like where she dives underwater. And she does it with an LED mermaid tail. So, like, how do you build LEDs that can survive saltwater immersion? She'll give her best tips. We have a guide for the Adafruit PCF 8575 GPIO breakout expander, if you want to know how to use that. Melissa wrote a guide for a project that she showed off, I think, at Hackaday SuperCon, I think, or some other, I don't remember what conference it was. People said they really loved it, so she wanted to write up how to make a Bluetooth-controlled Clue robot car. So you plug the Clue into this little microbit enclosure, and then you can control it with your phone, and it has little animations on the display. And then Jepler finally showed us off on Show and Tell. It's how to connect to an IBM PC XT keyboard, like the original, really big, doesn't have LEDs on it type keyboard with CircuitPython using PIO and an RP2040. So he's been going through all these old style keyboards and showing how to connect to them with CircuitPython, turn them into USB keyboards. Okay.
We're going to show the Jellyfish video and then the Light Up Mermaid video, and then I'm going to go into factory footage, and we'll see you on the other side. So sit back and enjoy all the sights and sounds.
Our oceans are full of life, and few species are more fascinating than the jellyfish. Jellyfish are more than 600 million years old, having survived all 5 mass extinction events. Some are deadly, some have bioluminescence, and one species may be immortal. This tutorial will show you how to create your own luminescent jellyfish out of iridescent vinyl and NeoPixel LEDs. Easily add endless light patterns with WLED software, with no coding required. You can even make multiple jellyfish and sync them up over your Wi-Fi network. This is a fairly easy project with no coding and just a little soldering. The end result is out of this world. See the full build tutorial at learn.adafruit.com.
is some factory footage. Okay. Lots of videos tonight. So we're going to play the how to make that RFID band project, and then we have a speed up, and then we'll see you on the other side again.
You can build your own Disney Magic Band scanner with electronics from Adafruit and CircuitPython. This project uses an RFID reader to scan your Disney Magic Bands and animates a strip of NeoPixels and plays your favorite sound effects. Powered by the Feather RP2040, this dev board is great for making props with lights and sounds. The RFID Whiz Kit makes it really easy to add RFID capabilities to your DIY projects. All you need to do to have it recognize your Magic Bands is hold it up to the RFID module and press the training button. This project uses CircuitPython to animate NeoPixels and plays audio files. The RFID module works like a button press, so whenever it's pressed, the NeoPixels animate and randomly plays an audio file from a list.
Excellent.
You can train up to 20 different RFID tags so you can add your whole Magic Band collection. To build your own, check out the Learn Guide at learn.adafruit.com.
Excellent.
We hope this inspires you to check out the WizKit and CircuitPython for your next RFID project.
Learn how to make all those grumpy things and scary things and more on 3D Hangouts. every Wednesday at 11:30 Eastern Time. The longest running 3D printing show in the world. Okay, let's jump right in.
On NPI.
I on NPI this week, brought to you by DigiKey and Adafruit, is RichTech.
That's right. I don't think we've done RichTech before. I try to make sure that we get every different company because they all have their unique products. So this week is from RichTech. It's the RT3549. If I got that part number right, memorized. So it is a BGA component, and it's very new. But I thought this was a very cool design, product idea. Something you would normally expect from one of the bigger, more expensive companies, but RichTech, I do really love their power supplies, their boost converters. I use them all the time. So I thought this was a very neat design. So especially, it's intended for laptops, but I think in tablets, but I think it could be useful for people doing other lighting projects as well. So like I said, this is the RT4539. So this is for me, it's like a 4-in-1 product. It's an NPI that does 4 things as one chip, and that tight integration, is going to make it, first off, very small, but also very efficient power-wise. So this is a 36-volt high-efficiency boost converter with I2C controlled 6-channel LED driver. So there's all the specs on the right, but let's go through basically the 4 things that it does. So the first thing is it's a boost converter. So the input supply voltage is 3 to 24 volts. It can give you up to 36 volt output. Let's go next image. So what's nice about this design is this chip, actually, you look at it, it has. I like how little you need to get it running. The switch is built in. You just need an inductor and a forward diode. You program in the boost converter specifications over I2C, but basically you can drive this from, because it goes from 3 to 24 volts, pretty much any battery that you're driving your system from, you can give the VIN, and the logic level for the MCU is different than the VIN. It's actually like you can use 1.8 volts or higher for that signaling. So your VIN can come from the battery, and your MCU can still use pull-ups on the enable, PWM, SCL and SDA I2C pins to do the control. So for example, just as one of many registers that are available, you want to change the boost switching frequency. This can be handy to avoid beat frequencies between the PWM, to avoid interference with the RF. Also, changing the frequency will change your efficiency versus your power output and your inductor usage. So you can tweak that in software. Of course, there's a lot more settings that you can adjust in software. But the first thing is that this is a boost converter. So that's first up, goes up to 36 volts. Second thing is it's a 6-channel constant current mirrored sync driver for LED strands. So actually, let's go back to here. So when you have LED backlights, again, this is designed for a tablet, although you could probably use it for other lighting projects. You want to have all your LEDs at the same color, temperature, and the same current, so that you have consistent, even color throughout the entire LED panel. And one way to do that is to have all the LEDs in a strand. They're all series connected, which is why you need that 36 volt boost converter, because you can have 10 LEDs in a row and now you need like 30 volts to drive them. But at least it forces you to make sure that they all have the exact same current between them. So you might end up with a panel, especially a really big panel. Once you get to over 5-inch diagonal or 3.5-inch diagonal, you'll have multiple strands of 5 to 10 LEDs. But you want them also to be balanced between them as well. Like, not just, obviously every LED in the strand has the same amount of current, but you also want each strand to individually have the same amount of current. And so if you look inside, there's actually a little current mirror on the bottom left there. There's a mux that provides the constant current control. Again, the constant current control is all done by I2C, and it's mirrored to each one. Each one has a matching transistor, emitter, whatever, source, resistor, comparator, so they all get equivalent current through them, and then there's also like a feedback loop that will let you know if the LED strand is open or closed. So that's good for debugging as well, so you don't have shorts, or if your LED panel is damaged, you can feed that back to the microcontroller that's running it. So part 1, boost converter. Part 2, constant current driver. Part 3, PWM driver. So obviously you do have constant current to sort of to set all the LEDs to the same brightness, but then constant current can do like very rough brightness control, but PWM is where you'll get a lot more precision. And what I thought was really neat is one of the things we have a guide on is why you don't want to use linear control of PWM for LEDs, because our eyes are logarithmic. And so that's why, if you do linear control, you'll notice that as you get to dimmer effects, you start to see more flicker and you have a lot less granularity. Whereas what our eyes really look like, that's especially true if you're using night mode, right? At night mode, it's like there's like off and then just a little bit light and then really light and then much, much brighter. Like it goes very quickly. Unless you have exponential control, as you see here, the PWM duty cycle is done exponentially for you, so that you get this smooth curve where there's a lot more control at the dimmer lights, and then as it gets brighter, it goes up very quickly. And this is what our brains like more than linear, and that's handled for you. So it's kind of nice. It's all built in again over this I2C connection. And then number 4 is there's all this other extra stuff that they added in over I2C control to make the lighting easier to handle. So for example, slope management, like you want to go from one brightness PWM curve to another, you can actually tell it, hey, do a ramp for me or a slope, and here's how gradually I want you to do it to control. So you're not sitting there like manually tweaking the PWM rate over and over again to get your linear slope. You just say, hey, go from this range to that range, do it in 512 milliseconds, and then you can check when it's done. So it's kind of like a 4-in-1 LED driver. Kind of neat. I thought it was like a really nice design, and again, it's designed for tablets and laptops because they get the best stuff. But I think this would be very useful also for there's user projects, or if you're doing like LED lighting, not backlight lighting, but just like you're controlling LEDs. All of this extra capability would be so great. I mean, just even the exponential PWM control is miles better than most LED drivers that I've seen for like automotive or commercial use.
Okay, and available on DigiKey. Check it out on DigiKey's site.
It's not in stock. It's very new.
It's super new.
It's super new, so there's not even a sign-up page yet.
Yeah.
However, if you're interested in this, do contact DigiKey Sales, and they will get you samples. I've found that's a very effective way to say, hey, I'm really interested in this chip.
Yeah.
Can you get me
this
samples?
This is cutting-edge ion NPI.
This is the NPIest of NPIs. I prefer to go with ones that are in stock, but this one I thought was too good to pass up.
All right.
On NPI.
Okie dokie, before we get into new products, the code is SPI Flash. Use it or lose it. You have a few hours. Fear of missing out. FOMO. Someone else is saving money and you're not. What are you going to do? What are you going to do? Let's do new products.
Yeah. New.
All right.
You said
Okay.
you shouldn't get in trouble. but
it'll be okay. All right. First up this week.
Okay, a revision, but it's a pretty big revision. This is the micro lipo. It's our plug into USB and charge a battery charger. We use this for our lipo batteries, and it's very convenient because again, I just love to plug into USB and then just charge up your battery. The older version had a jumper. It originally would come with 100 milliamps. And then there'd be a jumper on the bottom. You'd short that out, and then you'd get 500 milliamp charge rate. But I was kind of doing a bunch of revisions, and I was like, let's revise this as well as while we're at it, let's add a switch instead, because I made all the components 0603 instead of 0805. I tucked them all a little bit to the right, and then I actually had enough space to add a slide switch. So the slide switch, uses with any of our Adafruit batteries. Do watch out for the polarity. I also had polarity markers in a very, right next to the connector, but you can switch from low 100 milliamps to high 500 milliamps charge rate. So if you're having tiny little batteries, go with 100. If you're battery is over 500 milliamp hours, you can switch over to the charge rate to 5, and you'll charge up in an hour or less. It'll be much faster. So I thought this was a nice little update. So pick up a micro LiPo. It's a great way to get your batteries charged up. Next up, it is a QT-ification. Still going through a lot of our old boards that have I2C and making them STEMMA QT compatible so people can use them without needing to do soldering. So this is the SI5351. This is a really cool Scilabs chip that's a clock generator. We have a nice precision 25 megahertz crystal on there, and it generates 3 outputs. I think it's 8 kilohertz to 160 megahertz output. So good for if you just need I need a 10 megahertz reference clock, or you want to clock something, or a lot of people actually use it for RF projects. If you need a reference square wave, this will get it to you again. It's not sine wave; it's a square wave. And we're still going to stock the old version, which is a little bit wider, in case you want 3 SMA outputs, because this has 3 output pins, and each one gives you a different signal. So you can see 0, ground, 1, ground, 2. You control it over I2C. We have a library in Arduino, and we have a library in CircuitPython or Python. I think I'll just show really fast the 2 versions, just because it's a little. Hold on, let me zoom back out. Okay, can go to the overhead. Okay, so this is the new version, but again, we're going to still stock the old version. So the new version, it's much more compact, and you've got the STEMMA QT ports on the side. You can still connect one RP or SMA or RP SMA connector. Use the edge launch, and you just solder it on. The pads line up actually perfectly, so you can just solder right onto them. So here you go, and you have one output, and that's actually what most people want. If you want to have SMA connectors, edge launch connectors for all 3 outputs, you should keep with the old version, which looked like this, and had the 3 outputs at the top, and then also mimic down here. So there's 2 mechanical layouts. I think people have use for both, but for a lot of people, they really only need one output. So this is nice. Connect to I2C, and you get your outputs here. 3 of them on a breadboard, or 1 of them with a edge launch connector. But both use the same code, and both use the same crystals, chips, and everything. So they're cross-compatible.
Okie dokie. And the star of the show tonight, besides you, Lady Ada, our entire team and staff at Adafruit, our community, our customers, everybody who's hanging out here in the chat, and everybody who helps make this thing go, is
Spiffy Lash. No, it's the SPI Flash Breakout. So we had last week or the week before, we put in the QSPI Flash chips, and those were great for 3 volt microcontrollers and boards that especially wanted to use quad SPI Flash control. However, there's still a lot of people who are using 5 volt microcontrollers, and they want that level shifting. And in that case, I recommend this board, which will give you an SPI Flash chip. In this case, it's a W25Q16. That's a 16 megabit, 2 megabyte flash chip. That's the thing on the right. A 4050 logic level shifter, and a 3 volt regulator. So what is this used for? Well, if you're doing a lot of data logging, or you want to do data storage, we recommend a micro SD breakout board. And we sell those, and they're also level shifted. And what's nice about that is it's got fat file system. You can take out the SD card, put it into your computer, and remove and move files around, rename files. But once in a while, you don't need that much storage. You want something a lot lower cost, and a lot less power, and a lot less complexity. And that's where SPI Flash is going to do the job. So it's not wear leveled, but you have 100,000 writes. It's not organized in any format unless you want to. So if you want to format with little FS, you absolutely can. You want to use FAT? Go ahead. You want to treat it as one big flat memory file?
Yeah.
Totally cool.
You can write that on the back.
Do whatever you want. Yeah, put a little bit of space on the back so you can write stuff.
Yeah.
But we have once in a while we have projects where it's like you can data log to it. It's nice because it's mechanically stable. If once you solder into the board, there's no risk of like the micro SD card coming loose. You also don't have to deal with corruption because, again, it's one flat file system. We have Arduino libraries for it. It's kind of a well-known chip style. Also, if you have existing older projects that used DIP SPI flash, so these chips used to come in DIP format, and they don't anymore, and you're like, okay, I have to I want to fit something in place. This will do the job because they don't make 5-volt compatible SPI flash anymore, but this basically is the equivalent of a 5-volt SPI flash chip that's breadboard friendly. So I think still very useful if you don't need a ton of memory, which is would be an SD card. You don't need a tiny amount of memory, which would be an I2C EEPROM. These chips 2 to 16 megabytes of storage, and then format it how you like. And again, a universally understood chip. Almost every microcontroller board understands how to talk to SPI flash.
All right, don't forget the code is what we just talked about, SPI Flash. We're going to do questions right away because we're going to bounce tonight.
Yeah, we're right on time.
Yeah.
You think you're like, oh, let's go.
Yeah, I'm going to try to do that. So you can ask your questions. I have some lined up in Discord, adafruit.it/Discord. Go over there and we will start.
Okay.
First up, is a USB VID PID required for ESP32? It doesn't have native USB, but I'm also not fully versed in the WebBT workflow.
That's actually covered in Jepler's page. That it's in the guide. If it's a fixed VID PID, because you're using a USB serial converter, or there is no native USB, you would use a unique identifier, and the page shows you how to get a unique identifier. It's not a VID PID, but it's still a way for us to identify which board it is.
Okay. What's the latest with our Fluffy project?
It's happening. We're actually we had to take a break from that because it was extremely fun, but we had to focus on keeping stuff in stock.
Yeah.
But now that things are a lot better with the chip shortage, we're getting back to some projects.
Yep. Any 1,000 to 1,600 nanometer spectrometer suggestion?
That's above infrared, huh? I don't actually know of anything. I know that there was a spectrometer project or sensor from like this one Japanese company. I can't remember it. You actually probably have to find somebody who has built something and see what they use, because I don't know what sensors would do that range.
Okay. Next up, I think. Jeff might have some help on one, but this one, finding conveniently compact BSS 138 is too slow for NeoPixel 800 kilohertz data signal for compact SMD. Should I use the SN75 or something else to do that fast logic level shift from 3 volts to 5? UberGuide is awesome, but just points to bulky quad logic level shifter.
You could, if it's surface mount, you can go with a 74 AHCT or HCT. You definitely want the T in there, the last letter, because that will give you something that can take transistor level inputs and shift it up to 5 volts cleanly. Technically, the LVC series, while you can use it, and I use it, first off, make sure you can run off 5 volts. You have to be a 5 volt safe, and you want to make sure that it can trigger nicely at 3 volts and not, if your power ends up going a little bit higher, like 5.5, just make sure that you're still triggering it. But we just have a through-hole version because that's what most people want to use.
Okay. Do you suspect with the advent of CircuitPython 8 on ESP32, another wave of dual-core feature requests might turn up?
They might. I mean, we're waiting for Scott to come back to chat about how we want to handle dual-core support. We probably want to just pin some functionality. I don't know if we would necessarily allow people to choose what goes onto the second core, because there's a lot of locking stuff that has to handle, and I know Jepler and I chatted about this, but we'll revisit this more. But we'd probably put graphics handling or audio handling on the second core, Wi-Fi handling, and let user code run on the first core. We're not sure we want to necessarily have like anyone put any command, anything on any core they want, because there's a lot of we're not running a real-time operating system here. We're running an interpreter. There's also the coprocessor on the S3 that I know Jepler's looking at.
I don't know the answer to this. And does the WeAct STM32H750 work with the STM32 Cube IDE?
I don't see why not. And, pretty much everything works with the STM32 Cube ID. I haven't used it, but I know that it supports, pretty much every STM32 chipset.
Okay, note that we have Wi-Fi on the second core and ESP32 S3. Don't know if that's done on ESP32.
Yeah, I think we just haven't. We're still chugging through stuff.
Okay. I think that is it for questions. Thank you, everybody.
Wow. Perfect timing.
Got out. That's our show for tonight. Don't forget the code is SPI Flash. Use it until
Spiffy.
midnight tonight. Thank you so much for spending your Wednesday night with us. We very much appreciate it. This is our favorite time of the week, in addition to show and tell, where we get to hang out with some of y'all and talk about all the cool things we're all making and sharing. However things are going to work out in the future, I know it's going to be science, technology, engineering, people coming together and sharing all the cool things that they like to build together. So, that being said, it's been an Adafruit production. We'll see everybody next week. This is your moment of Zener.
Bye, everybody.